Let me show you two ways of doing this question. A lovely kind of intuitive way, and then one way which is a bit more brute force using the idea of arrangements. Both worth looking at because sometimes, you need to solve questions on arrangements, and what I'm going to show you will come in useful. So first of all, I'm going to write down Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. And I'm going to imagine that Margot picks Monday to go jogging. Then she can't go on Sunday or Tuesday. It will leave 1, 2, 3, 4 options for the other days that she can go jogging. But that would be true if she picked Wednesday. Let's say she picked Wednesday to go jogging, then she'd have these 4 options. So there are 7 days and there are 4 options for each. However, if you just look at my example, when I had Monday, Wednesday was an option, but then when I went to Wednesday, Monday was an option. So in fact, I've double counted because the Monday, Wednesday would appear in both of these lists, and you'd get like a double counting of pairs. So what we need to do right at the end is just divide by 2. So I'm going to get 14 as my answer, and that is a really neat way of doing this question. Here's the brute force way. It's still, I shouldn't downplay it, it's pretty good. So I'm imagining that I'm running, so jogging, and then not jogging, jogging, not jogging, not jogging, not jogging, not jogging. I'm arranging 7 things, and I want 2 of them to be J's, jogging days, and 5 of them to be not jogging days. Now, when you want to arrange 7 things, actually, you can arrange them in 7 factorial ways, which is 7 times 6 times 5 times 4 times 3 times 2 times 1. Don't need to actually write the times 1. I'm not actually going to go into detail on where that has come from. I'm assuming you've done a bit on arrangements. If not, then have a look at some of my other videos. I have covered it. I cover it in A-level maths, but also on some other maths challenge questions. Um, 7 factorial, but when some things are repeated, you have to kind of take that into account, and because you've basically double counted the j's, because if you swap these around now, it wouldn't make any difference. So we then divide by 2 factorial, and the same with the n's. If you arrange the n, like keep the j's where they are and arrange all the n's, then it wouldn't make any difference. We actually have to divide by 5 factorial for all the arrangements then. And then we would get 2 times 5 times 4 times 3 times 2. And you can actually cancel a load of these out. That's going to become 3. So we get 21. In fact, I kind of expanded it all out, but you can just look at this and see that you're going to get 7 times 6 because the 7 times 6 and times 5 factorial over 2 times 5 factorial, these cancel out. So that's actually a quicker way of doing it. Anyway, 21. But I have included when j is next to each other. Includes consecutive j's. So I need to take this 21 now, and as I told you, this is a bit more brute force. Need to actually minus all the different ways when j is next to each other. And the way of doing this is to kind of put it together like this. Imagine it's just one thing. So I've now got 6 things that I'm arranging. Okay, because this is like a single identity. I'm just going to like move this around to different places. But then I've got my 5 factorial for my n's. So actually there's 6 ways. I mean, essentially the jj can be at the front, or it can be here, or it can be here, 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 or here. That is it. 6 ways. So I take 21, and then I'm going to minus 6, which is going to give me 15. Now, I'm not quite there, am I? And actually, it's very easy to forget this last bit because we've kind of got there's a very special day that I've included, which I shouldn't have, and that is if we jog on well, the first day of the week, Monday, and on Sunday. So this is counted in my 15 at the moment, but I don't want it to be. Therefore, finally, I have to do 15 minus 1, which is 14. So this is actually how I did this question. Much more complicated, much easier to make a mistake. The only thing I'd say in this case is that, yeah, because you can see it's not 15, you can kind of work out that missing one. So 2 methods, just going to very quickly run through the second one again. How we rearrange 7 objects where 5 are the same and 2 are the same. We get 21 using this idea of arrangements and factorials. Subtract all the different ways where j is next to each other. There are 6 ways. Subtract that, but just remember this special case where j are actually at the opposite end because they're actually still next to each other, and then we get 14.